we're going to be working with, continuing to work with rational expressions and functions, and now we're going to be working with trying to simplify rational expressions. We'll start by first reviewing rational numbers and how to simplify rational numbers. So as review, remember from work that you probably have done earlier, if you have a rational number, for example, 16 divided by 14, you can write that rational number as 2 times 8 divided by 2 times 7. So anytime we have a common factor, and remember that anytime we multiply, we're talking about factors. Anytime we have a common factor, we can think of this as 2 over 2 times 8 over 7, but 2 over 2 is equal to 1, and so this is just equal to 8/7. Okay? And so what we're using here to do this is a property of rational numbers, which is the cancellation property. If we have a common factor, we can go ahead and cancel it out because we can replace it by 1, since 2 over 2 is equal to 1, and simplify our rational number to lowest terms. So 8/7 is the number 16/14 in lowest terms. Okay? And so in general then, if we have a number which is a times k over b times k, because it's multiplication, we have a common factor which is the k over k. We will cancel it out because k over k is equal to 1 and say that this reduces to a over b. Well, using the same property then, we're going to try to do this with rational expressions, and we're going to follow the same procedure. What we want to do is we want to simplify rational expressions. Another word for this is we want to express the rational expression in lowest terms. Simplify a rational expression means express it in lowest terms. Express the rational function in lowest terms. Okay? So it's in the same way that we worked with fractions or rational numbers, we will use that cancellation property. Okay? So let's do an example. Suppose we have the rational expression y squared minus 2y minus 3 divided by y squared minus 1. This is a rational expression. We have a polynomial over another polynomial. And now what we're going to try to do is factor the numerator, factor the denominator, and see if it has any common factors. You might remember that the numerator is a trinomial. If we can factor it at all, and that's not always possible for every polynomial, but if we can factor it, because this sign right here, we have a quadratic, and because this sign is a negative, that means the signs in the middle will be different. We'll have a plus and a minus. And so what we need is factors of 3, which give us a difference of 2. Well, 3 and 1 will work because 3 minus 1 is 2, right? And we need to put the bigger number with the negative, so we'll have a negative 3 here, a plus 1 here, and so this expression factors into y plus 1 times y minus 3. I encourage you to, every time that you factor a polynomial, multiply it back to check your work. And in particular, it's that middle term that you need to check. And so we will get that middle term by 1 times y minus 3 times y, which gives us a minus 2y, and that's what we need. The denominator is a product, is a difference of 2 squares, and you know how to factor that as y plus 1 times y minus 1. Now, let's look at this rational expression in factored form, and notice that we have a y plus 1 in the numerator and a y plus 1 in the denominator. That's a common factor. Factor means, remember, things that you're multiplying with the other parts of the numerator. In this case, we're multiplying y plus 1 times y minus 3. So each of those is called a factor. And so that word is very important. We need factors in order to simplify. The same thing down below, we have a y minus 1 times a y plus 1, and those are factors. And so if we have a common factor in the numerator and in the denominator, we can go ahead and cancel it out. And so the entire factor y plus 1 cancels with the entire factor y plus 1 in the denominator. And so we end up with y minus 3 over y minus 1. Okay? Now, be really careful when you come to this stage right here, because it's very tempting to cancel the y's right here. But at this point right here, the y in the numerator and the y in the denominator, the y's are not factors. So the y is not a factor of the numerator, nor is it a factor of the denominator. And so those y's cannot be canceled out. Just to give you an example, suppose you have the rational number 3 plus 2 over 3. You know that this number is equal to 5/3. But notice what happens if you cancel the 3's. If I were to do this 3 plus 2 over 3, and if I were to cancel the 3's, which by the way, this is incorrect. Anytime I write something like this, I'm always worried that this might stay in your minds. So it's an incorrect procedure that I'm doing right here. But if I were to cancel this, I would end up with a 2. Well, certainly 5/3 is not equal to 2, so I must have done something incorrect here. And that what I did was I canceled the 3's, which are not factors. 3's are not factors. So keep reminding yourself over and over again, you can cancel quantities which are factors. Those are the only ones that can be canceled. Now, let's go back and look a little bit earlier at the first part of the problem. We had a rational expression right here, and because it's a rational expression, then it's going to have a domain. And so when you figure the domain for a rational expression, you should figure it before you begin simplifying it. So the domain for this particular expression is all the values that do not make the denominator equal to 0. Let's look at it in factor form over here. For the denominator, we have y minus 1 times y plus 1. So for the domain, we do not want y minus 1 to be equal to 0, and we do not want y plus 1 to be equal to 0. Right? And therefore, what we need to do is we need to eliminate those values that give us those quantities equal to 0. So we will eliminate y equals plus or minus 1. That's the domain of the function. Y cannot be equal to plus or minus 1. Okay? It's important to do it at the beginning, because after you simplify, the expression looks like this, and all of a sudden you think, but what's wrong with y plus 1? With y minus 1. If I put a negative 1 here, I get a negative 2, and I don't get 0 in the denominator. That's true, except for the fact that you need to always go back to the original expression of the problem. For the original expression, I cannot use both of the values, plus 1 and minus 1. Therefore, the domain has to be for y not to be equal to those two numbers. Okay? All right. So now, we're going to do another helpful thing in simplifying fractions. And by the way, when we have the expression, as we did earlier, y squared minus 2y minus 3 over y squared minus 1, we said that this equaled y minus 3 over y minus 1. We simplified it, and now this part right here, y minus 3 over y minus 1, is in lowest terms. So when you're asked to simplify, what you're looking for is an expression in lowest terms.